All right, y'all. So we're doing a little fraction work today. So rational equations. So we talked about this before. Rational equations. This just means we're dealing with fractions. That's all it means. So fractions, decimals are rational equations. So everything that you're going to see right now are going to be fractions. So a little old school math here, just to kind of get your brain going. We know that when we're adding and subtracting fractions, we have to have the least common denominator. And that's what we're going to find in all of these. So we're just practicing with some easy ones first. So we have common denominator. So common denominator stands. We add the top, and then we simplify. So in this case, we would end up with 2/3. Okay? It's no different if we have an x on the top. So my denominator doesn't change. It's 9. And on the top, we have x plus 2x. So this is the same as 1x. So we would have 3x. This simplifies, and this would give us x over 3. Okay? Now, this is getting a little more complicated, so we see we have xy cubed. So we still have a common denominator. So because of that, we're just doing the math. Nothing changes. Denominator stays the same, and we just subtract. Right? So we have the same thing here. Y squared minus 5, y squared minus 5, these are the same. So we're going to combine like terms on the top. Because we're adding, it's just saying we're combining like terms. So we end up with 9y minus 3 over y squared minus 5. Well, I cannot, this is not a difference of squares because 5 is not a square. And I could factor out a 3 on the top, but it doesn't cancel with anything. So I'm just going to leave it. Okay? Now this one's a little bit different than addition because we have this subtraction. So this means I have to distribute that to all of the terms on the top. So I would have 7 minus y. So 6y, and 1 plus 5, because it's minus a minus. So 1 plus 5, which is 6, all over 2y. Now with this one, I'm not finished because I see that I have a 6 here, and a 6 here, and a 2 here. So those are all divisible by 2. So if I pull a 2 out on the top, I would have 3y plus 3 over 2y. And now I have factors. So this cancels with this, and I'm left with 3y plus 3 all over y, and that's my final answer for that one. All right? And this is important because this is kind of where we're going. So what does this look like? So when we have these more complicated ones that we have down here that no longer have a common denominator, the first thing that we're going to do is we're going to change the denominators into factored form. And when it's in factored form, we're going to see what we're missing. And then we're going to multiply both the numerator and the denominator by any missing factors. Okay? And then we're just going to add and subtract the numerator. So this first one's actually a little more tricky than the rest of them, I think. So what I'm going to do is I'm going to look at this, and I have a 5 and a 10. So what I'm going to do is just identify my common denominator right here. So this is a 5 and this is a 10. So the number has to be 10, right? And then I have x squared and x, so it's going to be x squared. And then I have y and y squared, so I'm going to have y squared. So this is going to be my common denominator. So if I look at this, the first thing I want to do is put this in factored form. So if I have this in factored form, my numerator is going to just stay 6, and I'm going to pull out, from both of these I can pull out a 5, I can pull out 1x, and I can pull out 1y. So 5x, y. That's what I can pull out as I factor this. So if I look at what's left, I pulled out the 5, I have an extra x, and I only have 1y, so I'm good. If I look at this next one, I'm going to pull out a 5xy, because I know that this is my common factor. So I'm left with a 2 and 1y. Okay, so why did I do this? Because I need to see what I have to do for the second step. Multiply the numerator and denominator by any missing factors. Well, this factor and this factor are the same. But what's missing over here is a 2y. So I multiply this guy, top and bottom, by 2y. And I'm going to multiply this guy by just x, because that's what's missing from over here. So if I multiply this all out, I get 2 times 5, which is 10, x times x, which is x squared, and y times y, which is y squared. Okay, same thing over here. 2 times 5, x times x, y times y. All right, so now I'm going to multiply through on the top. So I have 12y plus 5x. And we already said what our denominator is. It's 10x squared y squared. So this is my final answer. Now, you're going to see why I think this one is the hardest one that we have on this whole page, the first one. Because if we take this and we put it in factored form, I'm factoring the denominator. So if I factor the denominator, I'm going to have x plus 3, x plus 1. 3 plus 1 is 4, 3 times 1 is 3. Okay? Now over here, I'm going to factor this denominator, and I'm going to have x minus 5, x plus 1. So negative 5 plus 1 is negative 4. Negative 5 times 1 is negative 5. Okay, so what I'm doing is I'm looking for which factor is missing. Well, they both have the factor of x plus 1. But this one is missing the factor of x minus 5. And this one is missing the factor x plus 3. So my whole denominator is going to be x plus 3, which is this one, x plus 1, which is this one, and this one, right? I don't have two of them, it's just one of them, and then x minus 5. That's going to be this third one. So if this is my denominator, then when I multiply the top and the bottom by x minus 5, then I get this term. Over here I have the other two, and this gives me the third term. So now when I do the math on the top, I'm distributing, is what I'm doing. I have x squared minus 5x. Here I'm distributing a negative 3, so minus 3x minus 9. And as I simplify this and combine like terms, I'll have x squared minus 8x minus 9 over x plus 3, x plus 1, and x minus 5. Okay. So now I have to look at this numerator and see if I can factor this out. Right, so what I have is x minus 9, x plus 1 over x plus 3, x plus 1, x minus 5. And what you see is that this x plus 1 and this x plus 1 are going to cancel, and my final answer are just the factors that I have left. All right, let's go on to these next problems that we have down here. Okay, so factored form. I'm going to factor out an x, and then I have x minus 3. So x squared minus 3x. Over here I factor out a 3, and I have x minus 3. Okay, so this is good. I see that I have an x minus 3 here and an x minus 3 here. So my common denominator is going to be 3x times x minus 3. 3 and x, and then x minus 3. So I have to see what's missing. What's missing in this one is just 3, and what's missing in this one is just x. So this is going to simplify into 12 minus 6x. All right, 4 times 3 is 12, minus 6 times x, because I have everything else that I need. Okay, now, this in itself doesn't simplify, but I can get rid of this. This is divisible by 3, this is divisible by 3, and this is divisible by 3. So if I factor out a 3, I would have 4 minus 2x on the top, and I would have 3x times x minus 3 on the bottom. And what I see is that this 3 and this 3, those two factors cancel, and I have 4 minus 2x over x times x minus 3. And that's my final answer. Now, I could pull a 2 out here on the top, and I could make this 2 minus x, but this isn't going to cancel with anything, so I just left it. All right, so over here, difference of squares, x plus 5, x minus 5, and then this one's going to be x plus 5, x plus 1. Okay, so what does that make my common denominator? I have x plus 5, x minus 5. I already counted for this x plus 5 here, so I have x plus 1. So the two x plus 5s, x minus 5, x plus 1. So what's missing? Over here what's missing is x plus 1. And over here what's missing is x minus 5. So this gives me 4x plus 4 plus 6x minus 30. So I'm distributing 4x plus 4. I distribute this 6x minus 30 because I'm adding, nothing else changes. So when I simplify this, I'll have 10x minus 26 all over my denominator. Okay, now again, I could technically simplify this, but the only reason I would pull anything out of this numerator is to see if I could get it to cancel with something in the denominator. So I can't pull anything out of this numerator to give me x minus 5. So I'm just going to leave it like this. Okay. All right, so if we look at these two, what we see is we don't have anything that's common. We do not have a common denominator. So if I have this c minus 2 is what I need to add to this side, and c plus 2 is what I need to add to this side. So my common denominator is going to be c plus 2, c minus 2, which hopefully you see this as a difference of squares. I'm not going to do the math because I'm hoping something cancels out in the top. So when I distribute this, I have 2c squared minus 4c. Now this is a negative, so this is going to be minus 3c squared minus 6c. I distribute this, 3c squared, this becomes minus 6c. So when I do the math, I'm combining like terms. I have negative c squared minus 10c over c plus 2, c minus 2. So again, I could factor this top, but if I did that, then I wouldn't get anything to cancel. Let me just do that so you can see. If I factor out a negative c, then I'm left with c plus 10, and then on the bottom I have c plus 2, c minus 2. So this doesn't get me anything because it doesn't cancel with these. So this is just another way to write the equation that you have up above. Okay? All right, last one. So if I look at this, what you see is that I have 2x minus 1. I have 2 of them here, and I have 3 of them here, and I have 1 of them here. So what that means is that my denominator has to be 2x minus 1 cubed, because I have to have 3 of them because I have 3 here. Now because of that, that means over here I'm going to add just 1. I already have 2, so this gives me the third one. And then over here, I have to add 2 of them to get my third one. So if I distribute this through, I have 4x minus 2 plus 3, because nothing changes to this middle one. It's got a perfect common denominator. And then I could distribute this once I've FOILed this out. So if I FOIL this out, I have 4x squared minus 4x plus 1. That's this FOIL. Remember, this 2 here I don't distribute, I have to FOIL. So what this gives me is negative 16x squared, because this is a negative here, plus 16x minus 4. Okay, and so if I combine my like terms, I have negative 16x squared, and then I have 16 plus 4, so plus 20x. And then I have 1 minus 4, so minus 3. Now, what we did with everything up above is we were just simplifying. That's all we did. So now what we're doing is we're actually going to be solving these rational equations. And so for us to solve them, we are looking for, if there are multiple fractions on one or both sides, we are still looking for common denominators. Excuse me, I'm still looking for common denominator. Okay, and then this says here we want to watch out for domain restrictions. So because we're solving, denominators can't equal 0. All right, and you'll see what we mean here as I go through this. So if I look at this, I have, excuse me, 2x and 3x. So my common denominator on this guy is going to be 6x, the 2 and the 3. So what am I missing here? I'm missing a 3. So this becomes 9. This guy is missing a 2. 9 minus 10 over 6x equals 2. Okay, now I could find this, I could put this over a common denominator, but I don't need to because I only have 1x, and that 1x is in the denominator right here. So if I simplify this, I have negative 1 equals 12x. So to clear this fraction, I multiply this side by 6x, and I multiply this side by 6x. So this side goes away, and this side becomes 12x. So now when I simplify this, I get x equals negative 1 over 2. Or sorry, 1 over 12. Now when it says check for the denominator, domain restrictions, I can't have a denominator equal to 0. So if I put in negative 1/12 here or negative 1/12 here, I'm never going to get 0. So I know that that's right. Okay? Now with this one, this says that I have x times x plus 3. Here's my x. Here's my x plus 3. So this x plus 3 has to be my common denominator. So what's missing over here is x, and what's missing over here is x plus 3. So as I write this out, I would have x plus 2x plus 6. And then I have negative 3 over x plus 3. Now, this is the great part about solving rational equations. So I have this x plus 3, x plus 3. If I was to clear this denominator and I multiply this side by x plus 3, and I multiply this side by x plus 3, everything cancels out. So once the left side has a common denominator and the right side has a common denominator, these common denominators cancel out and you don't have fractions anymore. So they go away and I'm left with 3x plus 6 equals negative 3. Denominator's gone. So 3x equals negative 9, so x equals negative 3. So I have this value, x equals negative 3, but look what happens. If I take this value and I plug it in here, I get negative 3 plus 3, which gives me 0. So this is an extraneous solution. So this is no solution. So that's what this means up here when we say solving the denominator, it can't equal 0. We're looking for extraneous solutions. So when I plug this in, I get a denominator of 0, so it doesn't work. Now, I know I can plug in negative 3 here, and that works, but because it doesn't work here or here, technically what I've done is I've created this common denominator, so it doesn't work anywhere. Okay? So my denominator on this guy is going to be x times x plus 1. So this is my biggest one. This is what I need. So this guy is going to be x times x plus 1. And this one, all I need is an x. Okay? So here's what ends up happening. If I FOIL this out, I would have 2 times x squared plus x. So distribute x squared plus x. So 2x squared plus 2x minus 1. And then on the right side, I have 3x, and I have the same denominator. Now remember what we just said is if I have the same denominator on both sides of the equal sign, they go away. So I end up with 2x squared minus x minus 1. Hold on, I'm doing too much of this in my head. Let me step back. Plus 2x minus 1 equals 3x. Now, remember, when we're solving equations, when we're solving quadratics, it has to equal 0. So that's why I had that negative x. So I'm subtracting 3x, and I get 2x squared minus x minus 1 equals 0. So for me to find the solution to this, I could do complete the square, I could do quadratic formula, and I can do factoring. I'm going to try factoring because that's the easiest one. So I have 2x, I have x, this equals 0. My only two numbers that I can have here are 1. So I have negative 2 and positive 1. So x is going to be negative 1/2, because remember I set this equal to 0. I set this equal to 0 and I get 1. So if I look over here in the denominator, I can plug 1 in. I get 1 plus 1. So 1 plus 1 is 2. So this value of x equals 1 is okay. So this is my solution. I have two answers. Okay, one more on this page. So x minus 5, x plus 2, I'm going to factor this guy. And I have x minus 5, x plus 2. So what does that mean? That means over here I'm missing an x plus 2, and on this one I'm missing an x minus 5. This one has everything. So if I distribute this through, I have x squared plus 2x plus 3x minus 15 equals 7x. So x times x, x squared, distribute 2x. I go over here, this is positive, so plus 3x minus 15 equals 7x. And now we had common denominators on both sides, so I'm not even going to write my denominator because I know it goes away. So if I combine like terms, I have x squared. So here's 5, but I move this over, so minus 2x minus 15 equals 0. So my factors here, I'm going to have minus 5 and plus 3. Negative 15, negative 2. So my factors here are going to be 5 and negative 3. So if I look at this, if I plug 5 in here, I get 5 minus 5, which is 0. So that one doesn't work. So 5 is extraneous. So my only solution is x equals negative 3. And I didn't test this, but it doesn't matter. I can put a negative 3 in either one of those and I'm not going to get 0. Okay. Let's see. Looks like we have a couple more. Let's see. I don't know what I was going to say up here. So here's the good thing about this one. So, oh, I know what this says. If one fraction equals one fraction. So here I have one fraction and here I have one fraction. All I'm going to do is cross multiply. So here I have 5 times x plus 3. And then if I look at this one, it's going to equal 8x. So I have 5x plus 15 equals 8x. So 15 equals 3x. So x equals 5. Now we can test this easy enough. So 5 over 5 is 1. 5 plus 3 is 8. 8 over 8 is also 1. So we're good. Okay, same thing here. Now I have x minus 1, x plus 4. And that is going to equal this one, which equals 6. So this side I have to FOIL. So I'm going to have x squared plus 3x minus 4 equals 6. Right? So I FOILed this kind of in my head, but if you need to go over here and really FOIL it, then you can. So remember, it has to equal 0, so I have to move the 6 over. So now when I factor this, I would have x plus 5 and x minus 2. So my two values here are going to be -5 and +2. And I go up here and look. This is the only one that has a denominator. I can plug in either 5 or 2, and I'm good. Okay, now this is super important, so we're going to hit on this one more time. So the difference between expressions and equations. So I know everybody's like, okay, well, an equation means you've got an equal sign. It does mean you have an equal sign, but we're going to solve these differently. So when we have an equal sign, all we're doing here is cross multiplying. And you can cross multiply over the equal sign. Okay? So if we cross multiply over the equal sign, I'm going to have x plus 7 equals 5, x plus 3. Now, with this one, I have an addition sign and there's no equal sign. So here, I have to find a common denominator. I did not have to find a common denominator here because I'm cross multiplying over the equal sign. So my common denominator is going to be 5x plus 7. I have an x plus 7, I have a 5, so this guy needs an x plus 7, and this guy needs a 5. So I have x plus 7, plus 5, x plus 3. Okay, I'm going to pause the video, and I want you to solve both sides of this, and then we're going to talk about the answers. Okay, hopefully you have something that looks like this. So on this side where we had the expression, we found our common denominator. You've distributed your common denominator, which is what I had here. We combined like terms, and then we kept the common denominator. All right, so here's my common denominator. I have my common denominator here. Okay, now what I did, this 3 times 5 that's over here, is my factors of 15 are 3 and 5, 1 and 15. And so I looked to think, okay, maybe I could factor this, but I can't. There's no combination here that's going to give me 12. So I'm done. This is done. This is the expression. It's all done. I've got a bunch of x's in there, and that's okay. Over here, I have an equal sign. So I cross multiplied. When I cross multiplied, my denominators went away. I had to make this equal to 0 because with an equal sign, it has to equal something. I moved everything to one side of the equation, then I factored it, and then I set my factors equal to 0. So on this side, because I have an equal sign here, I end up with an equal sign in my equation. I have that equal sign, have to end it that way. Okay? All right, come see me if you have questions.